Hi everyone, my name is Sadali and you're watching Scientist Academy. So today I'm going to give you a crash or quick introduction to Mathematica, and this video is going to be helpful for undergraduate students who are right now studying in universities and are in first or second year of their university education. So this is going to be helpful for nearly every science student, but yeah, if you are from statistics background or any other mathematical science background such as economics, so it will be helpful for you. So I will be discussing so many little ideas which are very much relevant for your study, and it is definitely going to help you solve your mathematical problems using Mathematica. So I hope you will enjoy this video. So before starting this video, please like, share and subscribe to this channel, and please like this video as well. Okay, so let's start. So what is Mathematica? So Mathematica basically is a software which is based on a programming language which is called Wolfram language, and this software is simply a computer program created in 1988 by Stephen Wolfram. He was a physicist, and so this language is basically created by Stephen Wolfram. So Mathematica is a very powerful desktop computer program, and this is capable of solving your mathematical problems such as algebraic calculations, numerical approximations, and computer graphic, right? So you can solve any kind of problem that you want to solve, mathematical problem with Mathematica, right? If it is solvable, right? So using analytical solution calculations or numerical calculation, whatever is convenient for your problem, then you can solve it with the Mathematica. So this is a very powerful software for you to implement, right? So it is suitable for both numerical computation or calculation or symbolic calculations, right? Whenever you have whenever you have a mathematical question and the solution to that mathematical problem does not exist. Let's say you are solving a nonlinear differential equation whose exact solution does not exist, then you can use this numerical calculations in Mathematica to come up with the solution. Similarly, if you are doing some kind of pure exactly solvable problems, then you can use the symbolic programming in Mathematica that is going to give you exact solution to your problem. Yeah. And not only that, Mathematica is not just a programming language, but a software on which you can basically do word processing kind of problems, word processing kind of work. Like if you want to make a paper, if you want to write a poster, if you want to write a letter, or even if you want to make a PowerPoint presentation for your presentation or any other thing, then you can implement it on Mathematica as well. So these are some nice looking graphics which are basically created on Mathematica. So as you can see how complex these graphics are and how beautifully Mathematica has implemented this, which is in front of you, right? So let's move on. So Mathematica basically comprises of two parts. The first one is kernel, and you can call it an engine of the car. Let's say if you are looking at the car, then the engine is said to be kernel, and similarly if you are looking at the car and if you are interested in the design and look of the car, then it is called front end. So Mathematica simply comprises of two parts, kernel and front end. So kernel is the main part of this programming language, which basically accepts your command which you have given to Mathematica and processes them and send back the results to your computer screen, right? And this evaluates your command. So this is called evaluating the command. So kernel is more like ignition, starting and implementing and running a car. It's more like this thing, right? Similarly, front end is what you are seeing in front of you whenever you are opening Mathematica document, right? So whenever you open the Mathematica, then you basically encounter the screen, which is more like a paper, so a blank white paper. So that is basically called, in Mathematica, it is called notebook. So the extension of that file is .nb, notebook, right? So front end is what you are seeing in front of your Mathematica software, right? So this part of the front end, which is a part of Mathematica that handles such things as screen display, printing, and the creation of Mathematica document. So how does this programming language works, or Mathematica software works? So Mathematica, as I told you, Mathematica documents are called notebook, and notebook is built like a word processor, like Word that you're using usually in Windows PC, right? So you can type and edit command, send them to the kernel, and kernel evaluates, executes whatever you have given to as input to your Mathematica software. Then it displays the results and so saves your work as well. For example, if you can see, I have basically pasted the screenshot or the snapshot of the Mathematica file, Mathematica notebook, in which you can see there is IN1. So IN means input, 1 means the line number 1, the command line number 1, which is equal to 2 plus 2. 2 plus 2 is the input that you have given using your keyboard, and if you hit shift enter, remember the execution of code line in Mathematica is implemented through two keys. The first one is shift button and the second one is enter button. So if you press shift and enter, then you will basically guide kernel, yeah, you will basically, or you will tell kernel to execute your command. So in the end, so you the input that you have given here is gone into the kernel, and this processes each and everything that is required to solve this problem, and then it gives you output. So this is out1, means the output of line number input command number 1, which is 4. Similarly, if you give a second input, which is, let's say you are interested in plotting this equation, which is f of x is equal to x square. This is a parabolic equation. So if you plot this one, if you want to plot this one, just you need to use the command of Mathematica, built-in command, which is plot, right? This one, and you have to say plot what. So you have to write the function, and then you have to place comma, and then you have to say from where to where. So you have to set the limit from -5 to +5. So if you execute this line by hitting shift enter, then the output will be in front of your screen, which is the nice looking graph of parabola, right? So this is the basic, this is basically the snapshot of this notebook. So as you can see, this Mathematica kernel does whatever you want to do. You have to give the input and it is going to give you output, right? So then you can save it. So yeah, so you send command to be evaluated by holding down the shift key and pressing the enter key, as I told you. So you can do this, right? And similarly, another easy way is to evaluate by pressing the enter key at the right side of the keyboard, right? So what are the functionalities of the Mathematica? So how in for what purposes that you can use Mathematica? So there are so many things. Some of the things has already been discussed earlier during the start, but yeah, I have basically noted down these functionalities in this slide. So the first one is numerical computation, if you are interested in doing numerics. Similarly, problem solving, equation solving, if you give equation to the kernel, then it Mathematica software, then it is going to give you the answer. Then there is symbolic calculation, like if you are not interested in doing numerical computation, but you are interested in deriving something or proving something, like proving a theorem or deriving an equation, then you can do symbolic calculation using Mathematica. Similarly, you can solve your calculus problems. Graphics can be plotted using Mathematica. Similarly, you define your self-defined functions. So if you are interested in defining a function which is not there in Mathematica memory or Mathematica software, then you can define it on your own using the functionality of Mathematica, which is self-defining a function. Then you can deal with the list. List is a data type in Mathematica. So using list, you can create different vectors or matrices, right? And you can do different kind of computations which are already written below above this bullet line list. So you can do anything with these lists in Mathematica, whatever is your requirement. Similarly, you could do pattern matching in Mathematica. You can do image processing in Mathematica. Similarly, you can create animation, you can create games, you can even create websites in Mathematica as well. Although this is not usually used by different programmers in the world, but yeah, you can use Mathematica as well because this is a high level language, programming language. So what is the syntax of Mathematica? So remember that every command in Mathematica starts with the capital letter. For example, if you want to calculate the sine trigonometric ratio of a number which is x, so what you need to do is to write sin. Remember the fact that sin should start from the capital letter S, capital S, in, and then you have to put square brackets because the square bracket is the argument of sine function in Mathematica. So not only just this is used for sine, but you can use it for any kind of command. So after introducing any command, you have to put square brackets because that is going to be evaluated by this command. So if you write sine x, this is going to give you the sine x, right? So remember, so with no space in between, remember you cannot, you are not allowed to put space in the command, right? So remember, so as I told you, command starts from the capital letter, so the Mathematica is case sensitive when it comes to the commands, writing the commands. So yeah, so this is case sensitive. So that means the word fun, F-U-N, fun, if you write it with capital letter is different from if you write it in small letter, although it is same for in our daily life, but it is not same in Mathematica. So this is just a joke that I basically put in over here. So similarly, Mathematica uses a lot of brackets such as curly brackets, square brackets, and round brackets. So argument for any function is basically written in this square bracket argument, right? So square brackets are given for the argument. Similarly, curly brackets, which are also called braces, are used to make lists. So if you are interested in making lists, then you can use curly brackets, right? So similarly, expressions are cascaded by this square round brackets. So this expression, this third, fourth bullet will be discussed later when we encounter similar examples. So yes, there are special constants. So like if you write capital P and then I, then Mathematica understand this thing as the pi, which is an irrational number. So pi has got 3.1459 dash dash dash, the value of pi. Similarly, capital E is designated in Mathematica for exponential, right? Whose value is written in front of you. Similarly, I is for capital I is for iota, which is an imaginary number. Similarly, infinity, if you write capital I and then NFIT, NIT, NITY, so it is understood by Mathematica as infinity. So remember, do not use these special constant as variable in your code. So similarly, like usual arithmetic operators, so these are the operators that are used in Mathematica: plus, minus, multiply, divide, and power. So remember, the order is usually very important, so you have to keep track of the order as well. So next is n. N is a very famous command in Mathematica. So this is used for finding the numerical value of some expression. So if you write capital N, then you have to put the argument, and inside the argument you can place anything whose numerical value is required by you. So usually Mathematica gives answers to 6 digits, but if you compile Mathematica to give the value more than 6, then you can basically tell Mathematica, like here, if you are interested in finding the value of pi up till 100 digits, so you have to write numerical n argument pi comma 1000. So as you can see, this is the output of pi, the value of pi up to 1000 digits. So similarly, there are very famous mathematical functions which are built in Mathematica, like sqrt, with s being capital is the square root of x. Similarly, exp is exponential of x, Yeah, log of x is the log, which is natural log. Remember, when you are not giving the base, the value of base to log, then it is natural log. Similarly, log b comma x means this is giving you the log of x with respect to the base which is given by you. This can be log 2, log 10, log 5, whatever. Similarly, sine of x is obviously this sine function. Then it will give you the sine function of x, sine of x. Similarly, cos of x, tan of x. Similarly, if you write n with factorial sign exclamation mark, then Mathematica understand as the factorial of n. Similarly, if you are interested in finding the modulo of n, then you have to write m or d with m being capital and n is the modulo of n. Similarly, factor integer, if you are interested in finding the prime factor of n, then you can use the command factor integer. So if you write factor integer n, this will be giving you prime factor of n, right? So similarly, Mathematica is very much expert, or you can say genius, in doing graphics. So Mathematica incorporates a wide range of two-dimensional and three-dimensional graphical functions. The simple one is plot, which is going to give you a 2D plot, plane plot, right? Two-dimensional Cartesian plot. So here you can see if you want to find a if you want to plot the plot of function f or any variable f, then you have to write plot argument square brackets. You have to write the function over here, then you have to put comma, and then you have to start the curly bracket just to make sure what is the dependent variable, which is x over here, and then what is the minimum value of x. So you have to put it here, and then after comma you have to put x max, which is the maximum value of x. And if you are interested in finding that the graph or the plot of this function f in step of certain number, not continuous graph, rather the graph in step of some certain values of x, then you can even write as one more comma, and then you can define the width of x here, right? So this will basically give you the discrete the plot of f for discrete values of x, so you can do it as well. Similarly, this is the graph. So similarly, if you are interested in finding the multiple graph in a single picture, then you can take the plot function or command, and then you have to put square brackets, and then you have to write all the functions in this curly bracket with separation by comma, and then again you have to specify the limits of the dependent variable x from minimum to maximum. So you can plot several functions in this way in a single picture. So there are some examples, right? So this is the plot function, p being capital, is inside the plot argument. You can see x square is being plotted for the values of x ranging from -10 to +10. So this is a very nice plot. So similarly, if you are interested in finding the plot of two functions, let's say x square and sine x, then you can use this syntax here, and you have to use it here, like two functions are being put in this curly brackets being separated by comma, and then take another comma just to make sure that these are functions and these are the range of independent variable x from -5 to +5. So you can say this is the graph of two functions plotted on a single coordinate system, Cartesian coordinate. So this is the thing. So sometimes you are interested in finding the graph of certain function for a certain range of dependent variable. So you can do like this as well. So you can write plot function, plot the argument, plot with the argument square bracket, and then you have to write the sine function where the value of x ranges from -pi to +pi, but you are while being in these limits, right, limits of this independent variable, still you are interested in doing to clip or crop your function with respect to x, then you can use the plot range where it says the values of x should range from where the value of sine of x should range from -2 to +2, right? So you can do like this. So this is the plot range. So this is the thing. So you can see this is the thing. So yeah, this is the range for the dependent variable, not for the independent variable, not sine x. Similarly, you can see sine x is being plotted from -pi to +pi, but you are saying that plot range should be you're plotting the function from minus pi to plus pi, but then you say the plot range should be minus 2 pi to plus 2 pi. So as you can see, yeah, so yeah, minus 2 to plus 2. Yeah, I think there is a mistake over there. Yeah, just let me, yeah, no, sorry. So yeah, so you can define the range of not only the x-axis, rather y-axis as well, this way. Yeah, so you can, yeah, so x, the range of x is minus 2 pi to plus 2 pi, but then you have to use this thing as well, from minus 2 to plus 2. So similarly, you can see you can give a style to your plot by using plot style command. So you are doing the plot of, you're making the plot of x squared and sine x as we did earlier for the values of x ranging from minus 5 to plus 5. But you are saying Mathematica that plot style of my graph should be red and blue. So here the order is red and blue. So the first red color is being given to x square, and the blue color is being given to sine x. So you can see here the sinusoidal behavior is blue and red is the parabola, which is the plot of x square, right? So for other option, the command is option, right? So when I'm explicitly doing some detailed video on Mathematica, the graphics of Mathematica, then I will I will show you how basically complex plotting or the cosmetics of these plot functions can be modified using different option commands. So, but for now it's sufficient. So similarly, you can do three-dimensional plotting. For example, if you have a function f and you are interested in doing 3D plotting, because this function depends on two independent variables, let's say x and y. So if you need to write is plot 3D, because for 2D plots the command is just plot. But when you are doing 3D plotting, then you have to write it 3D, but remember the fact that D is capital over here. So this is there's a certain special case, right? So function with comma, and then you can see the range of independent variable x is defined over here this way, like the other commands we did earlier. Similarly for y, it is defined in this way. Remember, do not put x and y in the same curly bracket, right? So these are different. So just because these are independent variables, they are independent from each other, orthogonal. So yeah, you have to do this way. So as you can see, this function will plot this 3D plot 3D command will plot this function on z-axis, while other two axes are x and y, right? So you can see this is plot function. So here you can see this ranges from -3 to +3 and -3 to +3. So this is the sine, you can say the surface plot of sine xy. Similarly, as you can see, this is 3D plotting. Further options are there, like you are calculating the 3D, you are finding the 3D plot of sine 20 square root x square plus y square, but the values of x are from -1 to +1. Similarly, from -1 to +1 is the value of y, but you want to plot 50 points, so you write 50. Similarly, you are not interested in, like you can see here, and this 3D plot is bounded by these square boxes, this cube or box. So if you are not interested in showing this box in your output, then you can use this command box with forward arrow. You remember, this forward arrow can be written using the minus symbol or hyphen symbol with greater than key. If you write minus and then greater than key, and if you give the space, then automatically this minus with the greater than key will convert into this arrow. So false means you are not interested in finding plotting the box with the plot. So similarly, if you are not interested in showing your axis, so you can say axis. You can write axis with none. You remember, all these commands have capital letter in their start. None is the command, so n starts with capital N. None starts with capital N. Similarly, axis start with capital A, false starts with F, boxed starts with capital B. Yeah, similarly, so there are further options, right? You can observe, you can look at this. So you can pause the video and you can observe this thing. So similarly, you can define your own functions. Like a function, you can define a function this way. A function may return a symbol, a real number, a complex matrix, another function. So function By defining the function means the output of the function will whatever you are defining will be a real number, maybe would be real number or complex matrix or any other function. So any mathematical object is acceptable for this value of function. Or the function may be written using mathematical notation. Remember, you can write the function the same way as you do in your mathematics copies. So it may be created using programming constructs, for example, if, then, etc. Or it could even be written in another language entirely, Fortran or etc. So you can even write your functions, right? Be in can you can bring your functions which are already defined in different language such as Fortran or C right into Mathematica. So yeah. So what should be the names of function and variables? So Mathematica variables names can be long, right? So you can write the name of your variable to be of any length, but remember your variable should not start with the number. Similarly, just because Mathematica interprets says two dimension is two star dimension, right? So two dimension means if you write two dimension with two being the number in the from a at the very first of your variable, then it will interpret it as 2 multiplied by dimension. So please be aware of not using the number before any defining any function. So names can end with a number. Yeah, you can use the name of any variable for any variable, and that variable can be ended with number but not start with the number. Similarly, x1 is acceptable, right? So you can see x1 is acceptable. So similarly, yeah, you cannot write the operators in between the different letters of the variables, like a star x is different from ax, so please do not put a star x when you are interested in writing ax, right? So yeah, what is the syntax of the function? So it is in front of you. Remember, if you write the function, if you define the function, Mathematica does not gives the output instantaneously unless you basically want to find the value of that function. For example, so you can define the function in this way. If you can write, you have to write f of function of what. So you have to write f, then argument bracket, which is a square bracket, and then you have to write x. But remember, after writing x, this underscore should be there, and then you have to write the colon sign with equal. So this is the definition of function in expression for defining a function. For example, if you want to define a function which is x squared plus 3x, then what you have to do, you have to write f with square bracket for the argument of that function with the variable being x, and then after writing the variable in f, the argument of this f function, you have to put underscore, and after that you have to write your object to write colon with equal sign. So x squared plus 3x. So after that you have to write, if you have to punch shift enter, but remember it will not give you answer, right? Unless you define you are interested in finding the value of function, then in the next line you have to write f with the argument 4, and if you hit enter, it will give you answer 4 to the power 2 is 16 plus 3 into 2 is 6, so this will be giving you 22, right? So similarly, instead of writing the argument, yeah, if you are interested in finding the value of function for not for just for a number, rather for a variable, let's say a plus 1, right? So for any algebraic expression a plus 1, so it will even give you f of a plus 1 as well, the way you usually solve in your copies in mathematics course, right? So you can solve equations using Mathematica. So yeah, so yeah, even not only that, rather even you can basically solve matrix calculations here. So as you can see, you can define matrix in this way. So a is equal to curly brackets. Remember, as I told you, vectors or arrays are written in the form of curly brackets because the square bracket is designated for the argument. So this is the curly bracket. So behind the curly bracket, you can see this is first argument, first row, second row, third row. So this is a 3 cross 3 matrix. So you have to write in this way, right? So Yeah, if you write in Mathematica, it will look like this thing. So remember, so if you if you hit shift enter, then it will give you the output. Similarly, if you are interested in looking at this matrix in the elegant form like you usually see in mathematics books, so you can use the command matrix form where m is capital and form is capital. So if you write matrix form of the argument a, where A is the argument and A itself is a matrix, so it will give you matrix form. Similarly, you can use the traditional form as well. So if you want to see the traditional form, so traditional form of A is more like the textbook style matrix, right? So you can even use traditional form. So these are the basic menus. In menu, you can see these short keys from where you can do computations, right? You can bring any subscript, superscript, you can bring dagger, you can bring square root, you can bring, if you are not if you're lazy enough to write the code for command for the mathematical calculations, then you can use these palettes as well, these sorry dialog boxes in Mathematica menu. You can use these as well. Similarly, you can see determinant of A if you are interested in finding the determinant of A. So then what you have to do is you have to write capital D, and ET is enough to uh, make sure this is determinant. So Mathematica recognize determinant as DET, where with D being capital. So the determinant of this matrix is 0. Right. So if you want to find the reduced form of this matrix, which is the echelon form, so you can use this as well. Similarly, mathematical operations are being used and can be used, right? So for matrix multiplication, we use simple dot, right? So you can see if we define here the two matrices, then you are interested in finding the dot product, or sorry, the multiplication of A and B, then all you need to do is A dot B. It will give you the answer. So then if you want to use this output which is given in the recent line, then in the other line you just need to write percent sign. The percent sign is usually used in Mathematica to bring the most recent output is input over here in the next line. So then you can even write, instead of writing matrix form where percent being inside the argument, you can also use this double slash forward slash with matrix form. Usually you can usually if you don't want to go back to the initial of the line, the start of the line, then you can write it write the matrix form at the end of this line as well. So similarly, the transpose can be used where T is capital. So write transpose with square bracket as argument. Inside the argument, you have to write your matrix, and then this is the transpose of your matrix. And then if you want to write the matrix or transpose of the matrix in matrix form, then you can use the matrix form like earlier we did. So similarly, you can find the inverse this way, right? So yeah, so this is the end of the video, and I have basically placed a system of linear equations. So this is up to you how you can solve in Mathematica. So if you learn what we discussed today, then you can use this. So you can solve this equation. So even if you are not able to solve this equation, then you can wait, and I will basically come up with another videos where I will be showing how to solve set of linear equations. So thanks for watching this video.